So just for the sake of recording, I'll repeat myself. We are moving on to things like sine law, cosine law, the rest of the trigonometry section, end of chapter 4. But before we do that, I want to make sure that we understand cast rule, because it will pop up here and there, but we're not necessarily going to relearn it or review it then. I want to assume that everyone has mastered cast rule. So I'd open up the floor. Is there any questions from homework that you wanted to take up, you weren't quite sure, and you wanted clarification? No? How about this? Who would like to see another example? Okay, let's take a look. So I feel like at this point in time, maybe it's because it's after the test, a lot of people might not have had a chance to do the homework for whatever reasons. I will implore, I will really push you and say, don't leave it until last minute. Just keep on going a little bit every day, just like my test marking. We could do a textbook question, or we could do one from one of our handouts. What do you say? Textbook. It's a challenging one. Okay. Here's a question that might look a little different. So on page 239, number 11, it says the point P, which is -4 and 9, is on the terminal arm of angle A. So let's get really serious and even input some of the symbols, proper symbols. If only I was more adept with Microsoft Word and I knew how to find angle symbols. Did I skip that? No, I don't think I did. Is there a part for math? Oh, there it is. Is there an angle symbol that you see? Angle A. Okay. Part A says, determine the primary trig ratios for angle A and angle B, such that angle B has the same sign as angle A. So there's enough clues there to navigate around the Cartesian coordinate. And then it says, use a calculator and a diagram to determine the measures of angle A and angle B to the nearest degree. I'm actually gonna draw the diagram first anyways, because I think it's important. I highly recommend it when you're doing cast rule questions. Here we go. Point -4, 9 will give me a better idea if I were to draw this out. So I'm going to. Let's see. 9, 9. -4, 9 would be 1, 2, 3, 4, all the way up here somewhere. So that's like 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7, 8, 9. I skipped it. Okay, so that's -4 and 9. And just to help our eyes, there it is. This is the terminal arm on angle A. I don't know what that is, but it doesn't matter. We can call it theta for all I care. Determine the primary trig ratios for angle A as well as angle B, where angle B has the same sine values as angle A. We'll get to angle B later. Sine of angle A, cosine of angle A, and tangent of angle A is what I want. Good morning. Okay. Would you like me to complete it or would you like to chime in? Someone willing to sort of chime in on this question to see if you have a better understanding. Take a risk. How would you go about this? There's enough information to start talking about opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Go ahead. Sure. So -4, 9, we can create an imaginary triangle on the Cartesian coordinate where this is angle A. So don't worry about what that might be, right? Regardless, we're going to say the triangle created by angle A, in this particular case, would be opposite over hypotenuse. But on a Cartesian coordinate, it's the same as writing y over r, which means we're going to have to know what the radius is. Cosine at the same time is x over r, and tangent is going to be y over x. So let's figure out what the radius is. Yeah, go ahead. Yeah, Pythagorean theorem, right? This imaginary triangle being a 90-degree triangle, we can say that the radius squared is going to be the base of that triangle squared plus the height of that triangle squared, giving us 16 and 81. That's a 97. Well, that's unfortunate. The number isn't the best, but that's okay. Root of 97. Let's apply it. The y value is going to be 9 over root 97, which I don't like because it's a radical. 9 times 97 over 97. Cosine is going to be, let me thin out this pen stroke, x over r. So x would be -4 over root 97. And again, I don't like the roots, the radical in the denominator. So it would be and then y over x would be y over x. Done. So that's the first part of the question. I'll stop right there. Was there any questions of where the numbers came from or how we got to this conclusion? Because now is a good time to ask. Yep. Yes. I get what you're saying. So so the question was, we're dealing with the angle A, which is not this angle. Yet why are we pretending it's this angle we're dealing with and applying the x, the y, and the whatnot? Okay, that makes sense. Going back to our idea of cast rule. So if this angle, for example, if it was sine of 150 degrees, right? The interior angle would have been, so how about I use just for the sake of clarity, how about I use this as theta inside the triangle, okay? If angle A was 150 degrees, if that means the theta of the triangle itself is 30 degrees, right? What we are doing subconsciously here, or not subconsciously, what we're doing intentionally is pretending that the triangle created by 150 degrees is actually in the first quadrant. Why? Because the only difference between the triangle on the first quadrant and the triangle in the second quadrant is just an x value of a -4. So when you have an angle that's bigger than 90 degrees, we can pretend that the angle is the supplementary angle, the other angle that adds up to 180, and then solve it as if it was a regular 90-degree triangle. Does that make a bit of sense? So the idea again is the triangle that I have in the second quadrant created by the angle of 150 is the same as a triangle in the first quadrant created by the angle of 30. I just have to make sure that whenever I use a negative, an x value, that the x value is written as a negative and not a positive. That's it. Hope that makes some sense. And on that note, part B asks, I also have an angle B such that angle B has the same sine as angle A, but different other ratios, I guess. Okay, so if sine B is going to also equal 9 root 97, 97. Careful now. Which other coordinate, which other quadrant in a Cartesian plane has a sine value that's going to be positive? C, A, S, T. The question says that the sine value has to be the same. In other words, the sine value is going to be positive. Which other quadrant gives me a positive value? It's going to be quadrant 1. Okay? Which means sine is going to be positive. Sine is going to be 9 root 97 over 97. Cosine will also be 4 root 97 over 97. But because it's in the first quadrant, the x value is not a negative 4. It happens to be a positive 4. Cosine of angle B is going to be positive 4 97 over 97. And tangent B is going to be, again, same y value, positive x value. It's going to be positive 9 over 4. I'll stop there for a second while you sort of soak it in, because that's a bit of a jump. A lot of people, again, this would take a deeper understanding of cast rules. So think about it and ask away. Okay, so made it. Okay. Honest. Is there a part that's confusing to you? Is there a part that you'd like me to go through again? I'll try to break it down so that you can tell me this part or that part, okay? Part 1. The question said, right? I have a point -4, 9. What is the sine value if my base is a -4, my height is a 9? So this is where I got 9 root 97, -4 root 97, 9, -4. Was that confusing? If I asked you the same question, would you be able to understand, oh, this is my x value, that's my y value, and I could find radius? Can you do that? Okay. I'm going to go out on a limb here, but I have a feeling that you never really gave yourself an opportunity to really look at Castro. The way you are responding right now tells me it's still a fresh look to you. This is not something you've chewed on yet. You didn't even give yourself a chance. Because if you did, you'd give me a definite yes or a no. Right now, it's just like, I don't even know what he's talking about. And we've already had 2 days on this. I'm not sure what to expect of you. Because as my students, my standard for you is here. Just as I carry a certain standard for myself, I have standards and expectations of you. But if you're not going to walk through with me, then I'm going to pretend this is just a paycheck and I'm not going to care. Because there's very little I can do. As much as I want to support you, create these videos, answer your homework questions through video responses, give you as much feedback as possible, try to get the test back as soon as I can. If you're not motivated, then there's no point in me being here. You might as well just learn off a YouTube video of some dude that's more famous than I am. Why am I here? Okay. Don't stop. I know it. We just had a test. Don't stop. The world continues to turn whether you like it or not. It's to this point, people, and I'm this recording, so I don't know if I should say this, but there is there's a teacher in a school very close to us, a school that you might say used to be our rival, so to speak, if you know what school that is. Yes? Yes? There are certain math teachers there that are like, oh, transformations, AKDC. Well, you know A, D, and C from grade 10. Go teach yourself K. I don't have time to teach you transformations. You know how our chapter 2 and chapter 3 was majority transformations? Yes? You remember that? And I said it was gonna be on the test. Remember that? A big chunk of it will be on the test. Yeah. I told you it was going to be on the test, and still a lot of people did not deliver. There are people your age, people that are competing with you, that are teaching themselves and putting things into their own hands because their teacher is not willing to do so, and they are still succeeding. And I'm not saying this to shame you. I'm saying this as a wake-up call to see that there are people who are, through blood, sweat, and tears, doing what you may not want to do. But at the end of the day, let's say a month passes, 2 months passes, 6 months passes, a year passes, you won't remember, and they won't remember the pain of that moment. All you remember is what you were able to accomplish. They are pushing through whatever method they can to survive under their circumstances. And here we are, and we're discouraged over a test or whatnot, and not giving yourself even an opportunity to look at the textbook. Like, where are we standing here? What is your purpose here? Is it just to exist? Are you just trying to get through this class, bare minimum, and never touch math again? Fine. But as I said, my standards and expectation for you is higher than just existing on this earth. And whether you want to or not, I am going to demand that you give yourself a chance, that you give yourself an opportunity. And I say this because I'm not looking at just the marks. I'm looking at everything else that will produce the marks, like perseverance, like effort, like not giving up, like giving yourself a chance. Okay. I'm also talking about things like thinking outside the box. Because legitimately, other than maybe English, math, and maybe science, or maybe even history, there's very little other subjects in this world that forces you to think really deeply and critically and argue and fight and win. Or maybe like debating class, but there's no like debate class. It's just like a debating club. There's very few things in this world that force you to use that part of your brain to struggle, fight, and then win. It's very little. Math may not be a strong suit. That's fine. Neither was it for me. I don't think I told you my story, but I was subpar when I was in grade 6. And I was subpar all the way to grade 8. With a scary dad, I busted my butt and I became like top of school by grade 12. That's only because I wanted it. That's all I'll say. Okay. I'm going to move on. Hopefully, sometime in the future, you'll shoot me an email and be like, that question, Mr. Kim, I've been working on it just like you said, and I'm struggling. I don't understand anything, but at least I'm starting somewhere. I'm like, perfect. Let's start on our first baby step together. That's fine. Everyone starts somewhere. But from what I see right now, a lot of people haven't even started. That's why I'm upset. Okay, let's get to it. I want to talk about today's actual lesson. There's been enough of a delay. Okay, please take a look. So this is not on your sheet, but like the first sheet that you have in front of you for chapter 4.4, you can put a little bracket in there saying 4.5 is included because it's basically the same thing, except 4.4 is grade 10 stuff review. 4.5 is the addition of something in grade 11. Okay. Well, yes and no. 4.4 also has a little bit of grade 11 in there. 4.5 is basically looking at things in 3D. So I'll give you an example of that very soon. Okay. Given all three sides, assuming that you know SOHCAHTOA, here's a situation where SOHCAHTOA cannot be used because we don't have a right angle triangle. We are dealing with a scalene, an obtuse, an acute triangle, whatever you want to call it. There's all these different triangles that are not 90 degrees, obviously. So what do? From grade 10, you learned that there are two different relationships we can use, something called the sine law and something called the cosine law. I'm going to review both, starting with the cosine law because I think it's easier. It's just a formula. And if we ever have a test or an assignment or whatever, you can always bust out the formula. You don't have to memorize it. You just got to plug it in. But here's the thing. There's a lot of different letters. We just have to know where we plug in those letters. That's important. So we're going to hash that out as well. Okay. So this is something where you just have to sort of look and match, not as much thinking. So that's up your alley. Now might be a good time to start your homework and really get this under your belt. Here we go. Given all three sides or given two sides and a contained angle is the only situation we can use this thing called cosine law. Please remember that. If you are ever confused, be able to at least visually pick up the cues. If you have a triangle and they give you all three sides all around, in other words, SSS, cosine law will help you find some unknown piece in here. Cosine law will help you find any of the other unknown pieces. In this case, it can help you find any of the angles. If the triangle, the question gives you two sides with the angle between it, super important. The angle must be between it, then it will help you find, it will be the first step that you need to take to find all the other unknowns. If this angle that's given is not this one, but they gave you that one, or they gave you that one, in other words, the angle is not between the two sides, that's a sine law situation. You cannot be confused of it. So what is cosine law? Anyone remember off the top of their head? Don't look at the sheet. Your teacher may have forced you to memorize it. No? Well, it starts off with Pythagorean theorem. Okay? Depending on how intense your teacher got into multiple triangle questions in grade 10, they may have accidentally created this formula and showed you, haha, you're going to see this later on. If not, this is the cosine law. It is Pythagorean theorem plus a little extra. It's basically Pythagorean theorem for the 90-degree angles, but because it's not a 90-degree angle, we have to add something to compensate for it. What are we adding? It's a negative 2ab multiplied by cosine c. So let's hash out what numbers go where. Okay. C is always the angle. I'm going to call it the angle of interest. We are interested in this angle. That angle has to always go inside cosine, which means little c is the side that matches the angle. For example, if you want to find this angle right here, C would be 5 because it matches, it's the opposite side. If you wanted to find this angle here, for whatever reason, the question said I want that angle, then the value of C would be 6. It is the opposite side, the corresponding side to that angle. And lastly, if, all right, that's a color that you can't see on the screen, right? That's the green, okay? 6 would be thing. And if you're wondering what the angle is at the top of this triangle, the C value, the little c, would be 7. You have to be able to match the side and the angle. These two at the opposite ends of this formula are matching side angle pairs. The other two, well, you just got to watch out. Just plug it in AB and AB. A squared plus B squared, and AB is multiplying with -2 and then multiplying with the cosine of C. So let's see that in action. Okay, so here's a situation where it's all just side, side, side. Okay, so let's do it. Let's pretend we are interested in here. Okay, the left angle as theta. That means, as I said before, the matching side in this case is 6. So 6 squared, and the other two sides are just going to be plugged in. 5 squared, 7 squared, 2, 5, and 7, and then cosine of the angle that we do not know. And the rest is just algebra. And judging from the test, some people still need a little bit of refreshing for the algebra, or just rearranging an equation. We got 36, that's 25, that's 49. 2 times 5 is 10 times that's 70 cosine of C. My goal is to get this all alone. If you're not copying this down, that's fine on a separate piece of paper, but I know there's going to be so many people who make a silly mistake by subtracting. You're going to subtract 25 from both sides. You're going to subtract 49 from both sides. And then you're going to add 70 from both sides just because you're doing the same thing. That's wrong. What am I doing wrong? Go ahead, Lucas. Yeah, the -70 is multiplying with cosine. If it's a multiplication, the opposite operation is division. So let's take it one step at a time. Please don't make that mistake. You have no idea how many times this happens. It happens every year I teach grade 11 and grade 10 too, but grade 11, you should not be making this mistake. You should have had enough opportunities to make the mistake in grade 10 and fix it. So 36 minus 25 and minus 49 minus 25 minus 49. This gives me 11, -37. This is, I don't have enough space. I'm going to -37 is equal to negative 70 cosine big C. I'm not wrong, right? I just got to check. Give me a second. Let's see. So we've got 36, subtract 25, and subtract 49, negative 38. You are right. Okay. Now we can get rid of the negative 70 multiplying with cosine C by dividing both sides by 70, which gives me approximately 0.54285. I'm just going to say 543. Okay, I'm just going to round it for now. 3 decimal places for me is enough. I will specify how much I want on the question if it's like a test. Okay. And finishing off, that means angle C is going to be equal to the inverse cosine of 0.543, which gives me 57.1 degrees. So this is 57.1 degrees. It's so important. As long as you know how to match the side and angle and pair them correctly, the rest is just formulaic. All you have to do is recognize it's 3 sides, side, side, side. Question so far? This is all review of grade 10. Yeah. Okay. Moving on. In a different situation, we can have sides, angle, side. So SAS, side, side with an angle contained. It's the same idea. So if we want to find that side, I'm going to call this little c. Why? Because they're going to match, and that's going to be with cosine. So take a look. If c is what I'm looking for, that means the other 2 sides are going to be squared, and then the other 2 sides are going to be multiplying with cosine of the angle that matches with the unknown side. They have to match once again. Let me take a highlighter and do that for you. This C value and that angle have to be opposite pairs, matching side angle pairs. (25), 49, negative 70 cosine of 57.1. That comes to approximately 35.977. So that's basically 36. C is going to be plus minus 5.99. It's basically going to be approximately 6, which checks out. Yeah. So as opposed to going straight into sine law, what I'm going to do is let's practice some more cosine law questions, at least just one more. But I want to introduce a different kind of navigating system that you might run into in the textbook in case you've never gotten enough practice in grade 10. And that is called compass directions. So some of you might have learned it in geography, but dealing with angles and directions, it pops up in a lot of different places. Math, for example. And so I want to make sure everyone knows it. Otherwise, you won't be able to understand what the question is asking. You won't be able to draw your triangle. Questions? Or you want some time to copy this? I'll give you a couple more minutes while I try to pull out. No, I don't have to go to our classroom. Yeah, right here. Okay, finish this off. So I'm going to do some examples, but just to refresh you for geography, there are two different ways that we can communicate angles and direction. One is a 360 system. It's called a bearing. So if it's directly pointing north, we call that 0 degrees, a bearing of 0. But as we rotate in the clockwise direction, we increase. So from here, if I say I am going at a bearing of 90 degrees, it means I'm going east. If I'm going at a bearing of 180, it actually means south. I know that's a little confusing considering in the Cartesian coordinate, we've been working from the x-axis. But when we're dealing with bearings and direction, and let's say you're on a boat or a battleship or whatever, and you're trying to communicate to each other, north is default for them. And so north is 0 degrees. So to remove that confusion, another way we communicate directions is using compass directions. So if you take a look at your handout, I'm going to give you a couple of examples. Here we go. Trying to share this. Okay, so this is part of our handout. You will see that, for example, let's pretend I am going in this direction, and that is 20 degrees up from the x-axis, right? Let's pretend that's 20 degrees. Considering that's north and south, compass directions always start by saying north or south. So that arrow up here, is it closer towards the north or closer towards the south? I'm hoping you say that it's closer to the north. How far from north is it? In the what direction? 70 degrees in the eastern direction. So from north, I turned 70 degrees east. That's how we communicate compass directions. How about this? What if I have a direction going this way? And let's pretend this is, I don't know, let's call this 10 degrees. What's the proper compass direction for that? Go ahead. Yes, we are starting, it's closer to the south. So from south, what direction are we turning? 10 degrees in the east. So we say 10 degrees east. That's it. You will see this pop up in the textbook. So I just want you to know that's how we read it. So if I have a direction like this, and let's pretend this is 15 degrees from the x-axis here. Jonah? South, something west. So this is 15 degrees. So how far did I turn in the west direction? it'll be 90. So 90 right here. Minus 15, that gives me 75. So this bearing or compass direction would be south, 75 degrees west. Okay. Why is that important? Well, let me give you an example. Again, hint, hint. If I were to give you something like this on a quiz or a test, please take a look at the front of the second page. You will see an example called bearings, and I give you ship directions and ask you a question based on it. So this is the front of the second piece of paper. On the bottom, it says example bearings. It looks like, where is it? Sine law. Oh no, sorry. It's not the second piece of paper. No, it is the second piece of paper. Is it the second piece of paper? I think it's the back of the second piece of paper then. Sorry, I don't have mine stapled, so it's all wrong. How did I do this? It's the back of the second piece of paper. Sorry about that. Back of page 2. All right. So here it is. So this is an example that you might get from, let's say, a textbook. They don't think much of it. It's nothing different in terms of math, but requires you to understand this bearing system. Take a look. A radar station is tracking 2 ships. So let's draw it. If we're going to deal with triangles, it's best to draw it. So this is going to be my radar station. The first ship is 4.5 kilometers away in the direction north 42 east. So do your best here. I'm going to draw a dotted line in the north direction to help me navigate. And I'm going to turn, so that's north, turn 42 degrees in the east direction. So it's going to be something like that. And that is, here's a ship, okay? And it is 4.5 kilometers away. The other ship is 3.3 kilometers away from the station in the direction north 58 west. So 58 must be a little bit further away in this way, like that maybe. So from the north direction, I turned west by 58, and this is 3.3 kilometers. How far away are the 2 ships? If I were to redraw this, the triangle I'm dealing with is there. This is 3.3. That's 4.5. And the angle between is an addition of these two. It's 100 degrees. Do you see what I mean by the bearings? It's such a casual way of describing directions, but you have to understand it. And now that we have this triangle, you've drawn it out, the question asks for the distance between ship 1 and ship 2. What is that distance? Yep. Yeah, go for it. Yep. Well, not it's the souped up Pythagorean theorem. It's the cosine law. Absolutely. Recognize that the question indirectly gave you 2 half angles and you put them together, side, side, contained angle. Okay. So you have a situation like that. Okay, here's a question. It's basically bird's eye view. It's a 2D question. I am looking for the side D, and I know that I can use cosine law because I have the opposite angle with the two other sides. It is 3.3 squared, 4.5 squared, negative 2 times 3.3, 4.5 cosine of 100. If you know how to work your calculator, you'll be able to solve that in one single line. Let's see what you get. What's your answer? Another trap for a lot of students is just not knowing how their computer does BEDMAS. So sometimes they'll start plugging all these different things in, and a single typing mistake will just completely mess up their calculations. Final answer? Anyone? Yep. Yeah. So D squared should have been something like 36.29 something something something. So D is approximately 6.02 or 6.0, a small number, right? So it's approximately 6.0 kilometers. That's all it really is, at least for cosine. The question above, an example, the example that's right above it, is another cosine question where it gives you three sides. The only difficulty is I ask you to find all the unknowns. I ask you to solve the triangle. So you can try that for homework. Okay, I actually want to move on because this next piece is what's truly grade 11. So let me know once you're pretty good. If you're not getting this answer, it's probably just a calculator question because you did plug in the numbers correctly. Yeah. Okay. Just a little more time. Are we good? Just a little bit. Okay. For everyone else, I like you to. I'll remind you what cosine sine law is a little later. Um, once we try this question, but I'd like you to take a look at the back of page 1 now, the section that says sine law. I'd like you to read the example question and see if you can draw the triangle correctly. I'm curious to see what your triangle looks like. For starters, I can start for you. Oh, Lucas, you good? You okay? Yeah. All right. I'm going to start for you by first drawing the floor Oh, there's also an edit. I meant to erase Miss Malloy and Miss Evans because Miss Evans is dated. She's not supposed to be here. Pretend that's thing one. How far apart are thing one and thing two? Okay, let me read. Thing one and thing two are studying thunder clouds by launching a weather balloon into an active part of the cloud. That's an elaborate way of saying there's a balloon in the sky. The balloon is attached to two ropes, each held by thing one and two, respectively. One rope is 7.8 meters and makes an angle of 36 with the ground. The other rope is 5.9 meters long. Here's my thing one. Let's pretend they're like directly attached to the ground, okay? And this thing one is holding a string, nice and long, to a balloon in the sky. That is 7.8 meters long and makes an angle of 36 degrees to the ground. Can you finish the triangle? Sketch this. You don't have to draw thing one, but just sketch the triangle and show me what it looks like. Let me redraw this actually. I need some space. So 77.8 meters, 36 degrees. I'm asking you to find where the other, or draw where the other 5.9 meter line is supposed to be. Okay, 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 okay. Take a guess. Where is the other line? 5.9 meters. Okay, good. Okay, okay. You would use S, yes. But just hold off for a second. Okay, just label it. Where's the other? Where's the 5-point line? Come on, Noah. Okay. For everyone who has drawn it, every single one of you have drawn the same triangle. So congratulations. But you are also part of the 90% of the population or 95% of the population. Very few see it differently than you. So there's nothing wrong with that. I'm just saying. But what am I trying to say? Read between the lines. Very few see another triangle. And there is another triangle possible. No, not a right angle triangle. You can test it. I'm gonna show you how, right? But if you actually do SOHCAHTOA, you'll see that this is not 5.9. It's actually much shorter. So you're right in drawing your line like this. It has to be longer than this point. It's like over there. Where's the other one? Let's finish this off. And that's what makes this grade 11 and not grade 10. Grade 10, they're just like, okay, well, most likely thing two is probably here, right? And that's 5.9. Some teachers might have been like, well, how do you know it even touches the ground? You're going to have to test it, won't you? Well, you do, right? And so I'm actually going to test it right now. Let's start this question. Test. Is 5.9 meters long enough? So let's do it. Let's pretend we are dealing with a 90-degree triangle and do, let's see, opposite over hypotenuse. Sine of 36 degrees is equal to my height divided by the hypotenuse of 7.8. Height is sine 36 multiplied by 7.8. What is that? Either you're, and I'd like you to try to sort of write this a little smaller or have another piece of paper available because it's the answer is going to be a little bit longer than you might wish. Yep. Oh, it's like a dot for multiplication. Oh, yeah. That's multiplied by sine 36. Nathan, you got it? 4.58. So this dotted line is 4.58, right? Is 5.9 long enough to cover that? Absolutely. So 5.9 has to be diagonal. We're good, right? Confirmed. So let's pretend this is grade 9. We are going to go ahead, oh, sorry, pretend this is grade 10. We're going to go ahead and solve this triangle. This is an example of side angle if I go in this direction. But if I go in the other direction, you will get ASS. A lot of teachers won't like to write that, so they say side angle. But why I appreciate this acronym is because it will help you recognize that this is one of the grade 11 cases. When you get ass, is an ass of a problem because it's what we call an ambiguous case. What's the word ambiguous mean? It's an ambiguous case. What does the word ambiguous mean in English? It's ambiguous. No? Come on. Really? Ambiguous. Really? Oh my gosh. Okay. Okay. Ambiguous is another way of saying unsure. Ambiguous is another way of saying unclear. Okay. When you have SSA or ASS, it's unclear because this is not the only triangle we can draw. So there's more than one answer. Let's stay tuned. Let's pretend I didn't tell you that. Let's solve this using sine law. And then let me show you how I could still draw a second triangle out of this. But regardless of what triangle we draw, this default triangle that we have right here helps us because there is some calculations that we will overlap on. All right, here we go. Just as before, we always have to match the opposite angle and side, which means if you recall from grade 10, sine of 36 degrees is going to be proportioned with its opposite side. That is going to be, let's call this theta, the same ratio as the sine of theta and its opposite side. Let me use color to help distinguish. 36 degrees with 5.9. 36, 5.9. This matches up with, what color shows up? I think green does show up. Angle of theta with 7.8. Does that show up differently? Yes. Let's get sine theta all alone because we're looking for theta right now. I'm going to multiply both sides by 7.8 so I can get rid of the denominator. If I multiply both sides by 7.8, The right side is sine theta, and the left side is 7.8 times sine 36 divided by 5.9. Someone work that out for me? I mean, I have it here, but I think it's all good practice. Anyone? Yep. 0.77, and take that answer. If you do the inverse sine, you would get 50.99-ish. So I'm just going to say approximately 51 degrees. Did I find my answer? Not yet. I'm actually looking for the distance between thing 1 and thing 2, which means I need to pair that up with that angle. It's a roundabout way. But Zane, do you see where I'm going? If I have this green angle, or it looks yellow to you, as 51 degrees, can I find the third one? Do you remember what the relationship is between the three angles? Okay, this is something very important because you're going to be using it like the back of your hand. Any triangle, it has to all add up to 180. So if I have this triangle have 51 degrees here, right? So 180, so I'm going to bring this arrow to show my thought process. 180 subtract by 36 degrees, subtracted by 51 degrees will give you, let's call this alpha. Okay, we'll give you the alpha angle. The alpha angle is 87, so 87, 793 degrees. So if this alpha is 93 degrees, I have the orange pair, and now I have a ratio with the side I'm looking for. Sine, so you see this? I'm repeating it once again. Sine of 36 divided by sine of, divide by 5.9. And I'll highlight that in orange, just so you know I'm doing it once again. But this time, that ratio is going to equal sine of my alpha, 93, divided by the distance I am curious of. Ooh, this time the distance is on the denominator. That's okay. I'm curious as to know how your teacher taught you this. Did your teacher tell you to flip the fractions in grade 10? Louisa, what did your teacher tell you? Oh, okay. Okay, you could, right? Because if you flip this ratio, then you've basically, did the reciprocal of the other ratio. You could technically do that. But just not to confuse anyone, I'm going to say, just like how we multiply the denominator to get rid of it, let's multiply the denominator to get rid of it. So the left side is d times sine 36 over 5.9. And this side, d divided by d is 193. Next, I need to isolate d. So I'm going to multiply both sides by 5.9. Sorry for the large writing. So d times sine 36 is going to be 5.9 times sine 93. And lastly, I need to get d all alone. So I'm going to divide both sides by sine 36, giving me 5.9 sine 93 sine 36. And that you can plug into the calculator. Which happens to be about 10.02, approximately 10 meters. They're 10 meters apart. How much space do you have on your sheet? We did a lot of things here. If you're running out of space, you might want to take out another piece of paper because I'm going to show you the other triangle that's possible. And this is why it's annoying. And if you get a sine question, typically it's going to be SSA, and you're probably going to be asked to show me both possibilities. And so as opposed to this being worth, let's say 3 marks, it'll probably be worth 5 marks. And you'd be like, oh, there's more to this question. Why is it worth so many marks? Okay. Hint, hint. Here we go. I'm going to take a screenshot of this in case you ever want to see it, right? So I'll come back to this, okay? If you're copying, I'm sort of excited. Well, excited. I'm sort of desperate to show you that other triangle. If you have the opportunity, can you draw the same triangle again somewhere else? The triangle that I drew prior to asking you to finish. Can you do, oops. Can you do this again? Draw this triangle again. You ready? Okay. This is grade 11 stuff. Okay. This is grade 11 stuff. This is what we call the ambiguous case because the information the question gave you isn't enough. Let me draw back the dotted line to show you that this is supposed to be a 4.9, 4.8. What was it again? 4.58, sorry, 4.6, right? And the line that we had before, oops, was 5.9. So here it is. I'm glad that I have digital so I can actually show you. You see this line? This 5.99? I'm going to rotate it as if it was a grandfather clock. Tick, tock. I could draw the 5.9 in there. And I still create a triangle with a string that's 5.9 meters. Right? So if I were to take this as if it was a pendulum, or if thing 2 is there, and I swing it past my right angle triangle, I am creating another triangle, which let's take a look to see if it works. Thing one has a string of 7.8 meters and it makes an angle of 36 degrees with the ground. Thing two also has a rope and it's 5.9 meters. That's all the question said. So this situation being ASS could be a regular acute triangle or it could be an obtuse triangle. You got to watch out. Okay. And so luckily though, you have a lot of information helping you. I already told you that this is the same string. So this line and that line are equal, which means this little shaded area that I'm going to draw is an equilateral triangle. Your previous calculation already showed you that this angle is what? Look at your calculations. What angle is it? 51. That means this angle must also be 51, which means the interior obtuse angle inside the triangle must be 180 degrees, because that's a straight line, minus 51 degrees, 129 degrees. So let's redraw this triangle. We have long line, 5.9 line, the base that we're looking for. This is 36 degrees. This is 129 degrees. This is 7.8. This is 5.9. We are looking for that distance. But we already have two angles. So again, Zane, I'm coming to you. How do I get that third angle? Adds up to 180. So 180, take away 36, take away 129. That little sliver of an angle is, that's 65, 15 degrees. So we've got 36 orange, 5.9 is orange. And then this time my alpha is going to be 15 with the angle D. So we've got, I'm going to erase this portion, give myself some space. So, but this is my case 2. Okay, my other ambiguous case 2. Sine of 36 degrees paired with its opposite side, 5.9, is going to be equal to sine of 15 degrees divided by the unknown D value. And again, I don't like the fraction. Let's multiply both sides by D. D sine 36 over 5.9 equals sine 15. I don't like that fraction because I'm trying to isolate for D. Let's multiply both sides by 5.9. And of course, I never give myself enough space because of that rude little piece on the bottom. D sine 36 equals 5.9 sine 15. And then lastly, I can get D all alone by dividing both sides by sine 36. 5.9 sine 15 divided by sine 36. You should get approximately, so 2.5979, approximately 2.6 meters. So thing 2 could be 2.6 meters away or 10 meters away. Ambiguous case. Annoying. An ASS of a problem. But it helps to recognize it and to be able to see that we could find 2. You know what's funny? Well, not funny. But if you remember, in CAST rule, on the left side, we have a sine value that's going to be something. But in quadrant 2, when it is bigger than 90 degrees, I get the same answer as the angle that's smaller than 90 degrees. same application. But I'm not going to ask you to tie it up. I just need you to recognize that there's two answers when you have ASS. Grade 11, ambiguous case. All right. I'm going to stop there so we can take a bit of a break. We'll come back at 10:30. How about we do that? I don't have any ambiguous case questions we can try right away. You can probably see some. Yeah, it's like all these practice problems are all ambiguous case. I am going to, though, show you how even this, another grade 11 thing, even this can be applied to not 2D, but I could ask you for 3D questions. And you might see your spatial visual abilities being challenged by this section. That's 4.5. Okay, take a just under 20 minutes. Let's take a break and we'll come back 10:30.